All right, guys, so here's our lesson for the day. We're just going to do 3 types of problems here just to get you guys used to some more algebraically complex applications of the mean value theorems. It's the same thing we learned yesterday. It's just that the algebra is going to be a little bit more intensive today. And that's about it. So the lesson title is just 5.3, and it's just more mean value theorem. Okay, so we'll go ahead and we'll get started here. So the first one I want to look at with you guys is the rational expression type of problems. So let's go ahead and begin. So step 1 is we want to make sure that the mean value theorem applies. It does, but we're still going to go through the steps because technically you won't know that when you're doing problems on your own. So is it continuous on the closed interval 2 to 6? Well, this is a rational expression. It has a discontinuity when 4x minus 4 equals 0. The denominator cannot equal 0. And if you solve that, you're going to find out that's x equals 1. But x equals 1 is not on this interval. So, since the discontinuity is not on our interval, the function is continuous on the interval that we care about. Okay, so a function may have a discontinuity, but so long as it's not on the interval that we care about, then the MVT applies on that interval. Okay, now is it differentiable? On the open interval. Okay, well, to do that, we need to find our derivative. So let's do that. This is a quotient function. So the derivative, the negative in the front can just stay there for now, and that's very easy to forget about. So try not to forget about that little negative. It's very easy to forget about. So the derivative is going to be low d high minus high d low. Draw a line and square below. Now what I'm doing, by the way, is also step 3, so I'll just label it that now, but we need to do step 3 and step 1, so we might as well just do them together. So I'm going to go ahead and distribute the 2x here. We do want to simplify this time. It'll come in handy for later. So I'm going to distribute that in there. It's going to be 8x squared minus 8x. And that's going to be 4x squared. I'm not going to simplify the bottom. I don't think that's going to be necessary. We can usually just leave that. So we'll do 8x squared minus 4x squared. And there's that. So there's my derivative in its pretty simplified form. Now, is it differentiable on the interval? Well, once again, we just want, is there any discontinuities for this? Well, it's a rational function, so it actually has whatever makes the bottom equal 0. So just so you guys know, wherever this function's discontinuous at, it won't be differentiable there either. So it's not differentiable at x equals 1, and I'll just draw an arrow there because if it's not continuous, it's not differentiable. But that's okay. Because it's not on our interval once again. So the only place where it wasn't going to be differentiable would be at the same place it wasn't continuous. And that's usually what's going to happen with these types of functions here that are rational. So at this point, it's just kind of repetitive. So I just want you guys to know that in the future, when you have a rational expression, you just really need to find out where it's not continuous. If it's not continuous somewhere in the interval, then the MVT doesn't apply. But if it is continuous on the interval, then it's also going to be differentiable on the interval, because that's the only type of discontinuity that's going to exist even for the derivative, because the derivative has the same denominator as the original, so they end up having the same outcome. But anyway, so that's step 1. All right, let's go ahead and move on to step 2. Step 2 is to go ahead and find f of a minus b over a minus b, or vice versa. So my a is 2, my b is 6. So f of b is f of 6. Minus 4 is 20, and unfortunately we have a weird looking little fraction in there, but we'll make do. I believe it's going to be negative 9/5. So there's my f of b. Let's find our f of a. Okay, we got that. And so f of b minus f of a over b minus a is what we're trying to find in step 2. That's going to be negative 9/5 minus a negative 1 over 6 minus 2. We get double negatives. Now, here's one of the places where the algebra is a little bit intense. So what do? Well, we've dealt with this before. You multiply everything by the little denominator. And that gets rid of that little denominator. So now I've got negative 9 plus 5 over 30 minus 10, which is negative 4 over 20, which is negative 1/5. So there's my average rate of change, and that's the end of step 2. Now we've already done step 3. It's just finding the derivative. Once again, we had to do that for step 1. So now we're just going to do step 4. Step 4 is where you take your average rate of change and you set it equal to the derivative. So my average rate of change was negative 1/5, which we got from step 2. And from step 3, we got our derivative was negative, got to review what that was, just a second, I forgot. 4x squared minus 8x over 4x minus 4 squared. All right, so what do? Well, first of all, I'm going to go ahead and start by distributing this negative into the top. So that's going to give me negative 4x squared plus 8x. And this is where basically I'm just going to be showing you guys, how to handle the algebra here. On the bottom, I guess at this point I do want to go ahead and FOIL that out at this point. So, if you don't remember the shortcut I showed you guys, you can just, do it old school style. What is 4x minus 4 times 4x minus 4, right? You just do the first times the first. You do the last times the last. You multiply these together and double it. So that's going to be 16 times 2 is negative 32x. Okay. Okay, so my advice to begin with, after you guys get your setup going here, is to distribute the negative, if there is one, into the top, and to FOIL out the bottom. Okay, so if you want to write those down, distribute negative and FOIL. That's the first thing I do. The next thing I would do is I would cross multiply. So I would do, I would take this I would take this 5 down here, and and I'd multiply it to the top. And then I would take this denominator here and multiply it to the top. Now don't forget about the negative. I'm going to put that negative with the 1 there. So that's going to be a negative 1 being multiplied by that entire denominator. 16x squared minus 32x plus 16. There's that. So step 2, I would say cross multiply. So after you get your setup, step 1, distribute the negative and FOIL. Step 2, cross multiply. Watch out for those negatives. Watch out for those negatives. Next, I would go ahead and distribute. So distributing that into there and distributing that into there, we're going to get negative 20x squared plus 40x is equal to negative 16x squared plus 32x minus 16. And you guys are going to notice at this point that we have a quadratic. So we're going to want to move everything to one side. Okay, so I'm going to add 20x squared to both sides. And I'm going to subtract 40x from both sides. And that's going to leave me with 0 is equal to 4x squared minus 8x minus 16. Okay, now I'm going to reduce. You don't have to do this, but I prefer to. You guys may notice that all of these three numbers here could be divided by 2, which you're allowed to do so long as you also divide the other side by 2. And that's just going to give us a smaller polynomial to work with. Oh, you know what? Let me back up. I could have reduced by more than that. I could have reduced by 4. So let me reduce by 4 instead, actually. Give me an even easier one to do. Okay, so there's that. All right, so now what do we do? Well, you can either factor or use the quadratic formula. I already know that this one's not going to factor, but you're always welcome to try it. I prefer factoring, but unfortunately factoring is not always an option. But quadratic formula always works. I don't like quadratic formula because it's tedious and doesn't look pretty. I like the factoring, but whatever. So at this point, you could factor, if you like, or quadratic formula. And as I've already told you, on these problems, quadratic formulas, on this problem anyway, quadratic formula is going to be the way to go. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. My b is negative 2, my a is 1, and my c is negative 4. Four plus 16 is 20. Breaking down that square root. I don't know if you guys remember how to do that, but I can show you really quick if you forgot. What times what makes 20? Whatever has a pair can come out. So that would be 2 radical 5. So I don't know if you guys remember how to break down square roots or not, but that's how you do that. And then if you could find something that all 3 of these can be reduced by, then you go ahead and reduce it. And they can all be divided by 2, obviously. We don't really need the 1 on the bottom anymore. Now, you might want to look at these things as decimals, okay? So let's do that. 1 plus the square root of 5 is 3.236. Remember, in AP Calculus, we always go to the thousands place. And then 1 minus the square root of 5 is negative 1.236. Now remember, we only care about answers that are on the interval from 2 to 6, and that would be this one. That one's not on the interval. So there you go. So yes, the algebra is a little bit more intense on these ones. The steps that we use are the same, but the algebra, the solving processes, are a little bit more intense. So a practice problem for you right here. Go ahead and pause the video and do what you can with it. And when you unpause it, you'll see the solution on the board. All right, so here is the solution to the first 3 steps. I'll let you guys go ahead and study that. The MVT does apply for number 1. For number 2, f of b should have given you 0. F of a should have given you 15/8. Plugging it into your difference quotient, you would end up with an average rate of change of negative 5/8. And your step 3, the derivative, looks like this. All right, so go ahead and now I'm going to show you guys step 4. So we're going to set those things equal to each other, and then we're going to solve, which would look like this. All right, and so this is the solution. I get 2 and negative 2, but as you guys know, we want to get rid of the positive 2 because that's not on the interval that we care about. So really, there's only one answer, and the answer is negative 2 as our final answer. All right, let's go ahead and move on to a new type of problem. So this is another one that I want you guys to be ready to deal with, which is these problems with fraction exponents. So the first thing I want you guys to be aware of when you're dealing with these types of problems is that when you have a fraction exponent, you're dealing with a root function of some kind. In this case, it's a cube root function that's being squared. Okay, so that's kind of helpful to see it like that. It might be nice to rewrite it if you need to. But we'll go ahead and move on into our step 1. So now, first of all, does the MVT apply? Is it continuous on the interval? And the answer is yes in this case, because this is a cube root function. And cube root functions are continuous everywhere. The next thing we need is we need to decide, is it differentiable on our open interval? All right. Well, to do that, we need to find the derivative. Now, when you're doing a derivative, this is the easier way to look at it, is here, because we're just going to do the power rule. Now, I'm going to write my answer over here, and I'm going to call it step 3, because we have to find the derivative anyway in step 3, but we need that to do, shouldn't have called that 2, this is 1b. We need to do step 3 in order to finish 1b. So let's go ahead and do our derivative. So how do you find the derivative? Well, first of all, you start by multiplying the power to the front. So 2/3 times negative 1 is going to be negative 2/3. And you subtract 1 from the power. So 2/3 minus 1 is going to be negative 1/3. And then we're also going to multiply by the derivative of the inside, which is 5, because we have a little bit of a chain rule going on there. So that's your process for finding the derivative of these types of functions, just as a reminder. Now, I'm going to multiply that 5 times the negative 2/3, so I end up with negative 10/3. And since this is a negative 1/3, you guys, what that means is I'm going to put that in the denominator. And when you do that, it's not a negative exponent anymore, right? It becomes a positive. So that's the derivative. Now, since my derivative has a denominator, it could possibly have a discontinuity. It would be discontinuous if that part in the denominator with the x is discontinuous when 5x plus 5 equals 0. And if you subtract 5 and divide by 5, you're going to end up with negative 1. Okay? Now, is negative 1 on my interval? It's not. And you guys might think, yes, it is, Mr. Bailey. It's right there. How can you say it's not? Well, remember, this is an open interval. So my function only has one discontinuity, and it's at negative 1. But negative 1 is not on the open interval, because when you have an open interval, the endpoints are not they're not included in the interval. So since the function is not differentiable at x equals negative 1, but x equals negative 1 is not on the interval negative 3, negative 1, our function is differentiable on the interval negative 3 to negative 1. Okay, so that's an interesting little thing to pay attention to. Not only do we only care if it's in between the numbers, but it can be an endpoint when you're dealing with differentiability. Now, if you were checking for continuity and you ended up with a discontinuity at an endpoint here, that would not be okay, because that's a bracket. So it has to include the endpoints for continuity, but for differentiability it does not. Okay, so that's the end of step 1. Let's go ahead and move on into step 2. Now for step 2, we're going to plug the numbers in. And in my opinion, I like to use this form when I'm plugging them in. Okay, so I like to use the top form for derivatives, but I like to use the bottom form for evaluating. So let's go ahead and jump into play here. So I need to find out what is y of b. I guess I just stick with f. It doesn't say f, but I'll use f. F of b, and then I need to find out what f of a is. Now, this is a and this is b, so f of b means f of negative 1, which is going to be negative cube root of 5 times negative 1 plus 5. And all that's going to be squared. Now, this is going to be 0, and the cube root of 0 is 0. And when you square 0, you get 0. And if you multiply 0 by negative 1, you get 0. So the final answer is just going to be 0 for that one. Let's do f of negative 3 now. Forgot about my negative there in the front. Squish it in there. All right, so we have 5 times negative 3 plus 5, and we're going to be squaring it. All right, so 5 times a negative 3 is negative 15, and negative 15 plus 5 is negative 10. Now, before you guys cry foul here, cube roots can have negatives on the inside. That's okay. That's not a problem. Okay. Matter of fact, when you take the cube root of a number, like for instance, if I ask you guys what's the cube root of 8, you know the answer is 2. What's the cube root of negative 8? It's negative 2. So basically, when you have a negative inside of a cube root, it just means you're going to have a negative answer. So you could just take the negative out if you want. And since we're squaring it, that square is going to cancel that negative. And so now we're going to end up with this negative still being there, but this negative getting canceled out. And now we have the cube root of 10 being squared. Okay. All right. Let's see. I'm not sure if it'll be easy to leave it like that, or if it might be easier just to rewrite it like this. We'll see. We'll see. For now, we'll just leave it like that. Either way, we'll see which one comes in more friendly as we're trying to do it. But I'm not done with step 2 yet, because in step 2, we also need to find out what f of b minus f of a over b minus a is. Now we've got f of b at the top is 0. F of a we just figured out is negative cube root of 10 squared. And in the denominator we have b minus a. Let's clean this up a little bit. So this negative is going to cancel that negative. This is going to become plus, and so I'm going to be left with the cube root of 10 squared all over 2. All right, cool enough, and I think that's good enough for step 2. So I'm done on step 2. That's my average rate of change. Here's my derivative. So now I just need to set that piece equal to this piece, and we're ready to solve. So I think I will go ahead and just change that into a fraction instead. So we have 10 over 2, and that 10 is being raised to the 2/3 power, is equal to my derivative, which is negative 10 over 3 times 5x plus 5 to the 1/3. All right, now what are we going to do here? What we're going to do is I don't like those fraction powers. So that's the first thing that I'm going to get rid of. So here we go. Step 1 is raise both sides to the power of whatever that little power denominator is. So I'm going to cube both sides. And our goal is to cancel the fraction power out. Okay? So I'm going to raise both sides to the 3rd power. So when you raise 2/3 to the 3rd power, 2/3 times 3, this one is going to cancel with that 3, and we're just going to be left with 2. So we're left with 10 squared now because the denominator cancels. And we also want to cube the bottom. 2 to the 3rd power is 8. For this one, we want to cube negative 10. We also need to cube that 3 down there. And then we also want to cube this. Now when you cube this one, 1/3 is going to get multiplied by the 3. It's going to cancel out, and it's just going to leave you with a power of 1. Okay? So let's simplify this even more. We have 100 now over 8 is equal to negative 1,000 over 27. And we don't really need that power anymore on the parentheses because it's just 1. So there's that. Might be nice if we can reduce this a little bit. Like I see this side can reduce, so I would divide the top and the bottom by 2. Actually, we can go farther than that. We can divide the top and the bottom by 4. Get some smaller numbers that way. I don't see any other reducing that we can do, though. All right, and once again, we're going to do what we did on the last problem, which is cross multiply. So I'm going to multiply bottom times top, bottom times top. So it's going to be 25 times 27 times 5x plus 5 is equal to 2 times negative 1,000. All right, so I'm going to use a calculator here. 25 times 27, that's 675. Over here, that's negative 2,000. All right, the next thing I'm going to do is I'm going to distribute. So 675 times 5 is that. And then we just have a nice little equation we need to solve. And I'm going to use my calculator to reduce that number. Just a moment, typing it in. I end up with 43 over 27, and it's negative. All right, and so there it is, cross multiply, and then after that, you should be able to solve. All right, so the trick here with these ones, once you get to this step once again, is to raise both sides to the power of whatever is down there. And you have to do it to everything. Okay, so you have to raise this to the third power, this to the third power, this to the third power, this, and this. And when you do that, it'll cancel out the fraction powers so that you have just normal powers. After that, you just cross multiply and solve. So that's the algebraic strategy I would encourage you guys to be aware of for these types of problems. All right, guys, so here's one for you. Notice that this is a square root. Go ahead and see what you guys can do. And when you unpause the video, you will see the solution. All right, so there's our first 3 steps. I don't imagine you guys would need much explanation for steps 2 and 3. But let's talk about step 1 a little bit before I show you the rest of the problem. So square root functions are continuous anytime the denominator is, not the denominator, I'm sorry, the radicand is what it's called. That's the stuff inside the parentheses. Anytime the radicand is greater than or equal to 0. So that would mean that it's continuous if negative 6x plus 24 is greater than or equal to 0. And when you solve that, you get this. Now I want you guys to notice the sign flipped. And the sign flipped because you have to divide by a negative to solve for x. And when you do that, the sign flips. So this function is continuous for all values of x that are less than or equal to 4. Now look at this interval. Are all the numbers on that interval less than or equal to 4? Yes, they are. So this function is continuous on the interval that we care about. Is it differentiable? Well, to do that, we need to jump over here to step 3 and look at our derivative. It's only going to be non-differentiable if the denominator equals 0. So x cannot equal 4. But the good news is when you're doing differentiability, my 4, even though it's there, it's not included because it's an endpoint with a parenthesis on it. So it has this function has a place where it's not differentiable, but it doesn't matter because that point is not on this interval that we care about for differentiability. So that's that. But anyway, I'll let you guys go ahead and study that, and I'm going to move on to steps 4 and 5 at this point. I just realized my step 3 had a slight error. This was supposed to be a negative 6 here, which will mean that this has a negative on top. My bad. All right, now I'll move on to steps 4 and 5. All right, let you guys study this. Most of it speaks for itself pretty well. The only thing that's a little bit different is that since there's a negative here in the front of this 18, I thought it would be wise to rewrite that as negative 1 times 18. So that way you recognize that when you square everything, I forgot my 2 over there. When you square everything, that negative gets squared, so it becomes a positive. But the rest of the steps, no real big secrets there. I guess something I did that maybe you didn't do, but it shouldn't matter in the long run, is I decided to reduce that fraction here so I have smaller things to deal with. But other than that, I end up with 13/4, and that should be on our interval, and so we're good to go. And life just wouldn't be complete unless we had a trig example, right? I knew you guys were wanting that. You're like, Mr. Bailey, where's the trig example? You know how we love that stuff. I'm like, all right, cool. I can do that for you. All right, so let's begin here. Number 5, trig. We got to start by deciding, does the MVT apply to this? Is it continuous on the interval? It is, because both of these are sine functions, and sine functions are always continuous everywhere. And it doesn't matter if you square them or what, they're just going to be continuous no matter what. So the answer is yes, it's continuous everywhere. But we'll just put our interval, because that's all we really care about. But it's continuous everywhere. All right, is it differentiable on our open interval? Well, to do that, we need, of course, to jump over here to step 3 and find our derivative. So let's do that. Y prime, the derivative of sine squared. That's a chain rule. I'm going to do the power rule first. I'm going to multiply the 2 to the front. And then I'm going to multiply it by the derivative of the inside, the sine, which is cosine. And then we're going to take the derivative of sine, which is cosine also. And there's my derivative. Now, does that have any discontinuities? No. Sine is continuous everywhere. Cosine is continuous everywhere. So when you multiply these and add that, you're still going to get continuous everywhere because everything's continuous. So yes, it's differentiable, we should say. Shouldn't say it's, we could say the function is differentiable on 7 pi over 6, and that's supposed to be a parenthesis, and 11 pi over 6. So we're good. All right, step 2. Here we go. We need to figure out what f of 11 pi over 6 is. So that's going to be fun. Sine squared of 11 pi over 6 plus sine of 11 pi over 6. All right, well, using your unit circle or your trig reference sheet, you might recall that 11 pi over 6 for sine is negative 1/2. Negative 1/2 squared is a positive 1/4. And if you do 1/4 minus 1/2, getting a common denominator here, we end up with 1/4 minus 2/4, which is negative 1/4. So there's my f of 11 pi over 6. Let's go ahead and do the next one. F of 7 pi over 6. I believe it's actually the same answer because 7 pi over 6, sine of that is going to be the same thing. It's negative 1/2. And when you plug it in and simplify, you're still going to get the same outcome. So we actually get the same answer twice there. All right, let's go ahead and do step 4 now. Step 4 is where we take, oh, actually, we're not done with step 2 yet, my bad. We need to finish step 2. Step 2 is where you do f of b minus f of a over b minus a. Now, we could go through the work of trying to simplify this, but as you guys can see, we end up with 0 on the top. Anytime you get 0 on the top, the answer is just 0. So long as you don't have 0 on the bottom, which it's not. So we end up with 0. So the average rate of change on that interval would be 0. Now I'm ready for step 4. So for step 4, we're going to take that average rate of change, which is 0, and we're going to set it equal to our derivative, and we're going to solve for x. So average rate of change is 0. My derivative is 2 sine x cosine x. How do we solve this? Well, we did this one a little bit earlier, I think, if I'm not mistaken. For this one, we're going to start by factoring out a cosine. As you guys can see, there's 2 terms here. We have this term and this term. They both have a cosine in common, so I'm going to take a cosine out. Now, if I do that, it's going to leave me with 2 sine x plus 1. And then we set each piece equal to 0, and we solve. Right. Now, cosine of x is equal to 0 at a lot of places on the unit circle. It equals 0 at pi over 2. And it also equals 0 at 3 pi over 2. So we have two answers for that one. But we only want the ones that are in between these two. Now, if you know your unit circle, 7 pi over 6 is here, and 11 pi over 6 is here. 3 pi over 2 is here. So 3 pi over 2 is the one that's in between those two numbers. Pi over 2 is up here, so we're not going to use that one. It's not on the interval that we care about. As for this guy here, we're going to minus 1 on both sides. We're going to divide by 2. And where does sine equal negative half? Well, interestingly enough, sine equals negative half at those endpoints. So at x equals 11 pi over 6 and also 7 pi over 6. So there are those three values as solutions. That one, and that one. Okay, so here's one for you guys to do. Now, just so you guys know about the interval here, I'm not sure if it's going to matter a whole lot. Might come up a little bit. Pi is right here on the unit circle. Negative pi is also right here. So positive pi is if you're going clockwise. Negative pi is if you're going counterclockwise. So if we're going from negative pi to positive pi, that means we're starting at negative pi and going all the way around until we get to positive pi. Just think of it that way and see if that helps you guys out. But go ahead and pause the video and do as much of this as you can. So here's the first three steps. The MVT does apply pretty much for the same reason as my example. It's sine, and there's an x here. Both of those are continuous everywhere, so of course it's continuous everywhere. The derivative, which is over here, has a cosine in it, which is continuous everywhere. So that means it's differentiable everywhere as well. So the MVT applies. There has to be a number on this interval such that when you plug it into the derivative, you get the same answer as the average rate of change. Step 2, we're going to plug in the endpoints. F of pi is pi, and f of negative pi is negative pi. And then we plug it into our difference quotient, and we end up with 1. The derivative is over here, as we said already. And now we're ready for the last step. And this one has two solutions, pi over 2 and negative pi over 2. Remember, we're starting on our unit circle at negative pi, right? And then we're ending at positive pi. So we start here, and by the time you get here at negative pi over 2, cosine equals 0 there. And then you come up here and all the way around, and when you get up here to the top at positive pi over 2, cosine equals 0 again. And then we keep going until we get there. So there are 2 points on the unit circle where cosine equals 0, and you end up with pi over 2 and negative pi over 2 on that interval. And so there is our final solution to that one. All right? And that's where we will end it for the day. And we'll see you guys next time.